recording here. I don't know if you saw that's the wrong Moodle. You didn't see anything. Hear no evil, see no evil. Oh, and I just put lab 3 on here, but it's not on here. Anyways. So they're Moodle quizzes. Yeah, I know them. You saw them? They're nice and short. Did you have a look at some? No, I didn't get it. You're like, no, I don't want to. I'm not prepared. So I posted some because I finally got that. I finally got test bank in. And so what I wanted to do, because they're actually really very good questions, so we're just going to use them. Right? They're very thorough. They're from the textbook, right? And so you should be able to find everything in the textbook. So I said which chapter they're from, right? Chapter 1, 2, 3, 4. There were a couple of sections in chapter 4 that we didn't get to, right? They're not in here. But then I also posted these extra practice problems. Those are just for extra review, right? So these I think are little. Let's have a look at one. Chapter 1. You get 3 attempts. You'll only need 1, I promise, because it just takes your highest grade. But also, if you pick an answer, right, even if I don't know what it is, you can check it. You get 3 submissions, right? You can check it as many times as you want. It's all multiple choice. You really don't need. It's not going to be terrible, right? Of course, use this to study for the test, because what I've decided to do is, hey, it shows up all nice. That was a guess, guys. I just went for one. So what I've decided to do is, I can either print these off, or are you okay to just write the quiz, like the test, on your laptops in a Moodle quiz? Just because reading typed stuff is easier, right? And then we can just do it as a Moodle quiz. So what I'll do is, because I've got a quiz in there that I like, they actually just give it to you. I'm like, hey, I like all these problems. Great. Let's use that as our test, right? And so, because what we're testing on is Unit A, there's a Unit A test. Hey, it makes sense. Great. Cool. So that's what I'll do is, and it gives you the option to print it off, of course, but I just kind of felt like that was a little bit silly, right? And so definitely bring your laptops for the quiz next day so that we can do the quiz on Moodle. I'll make a note of that. But yeah, so here, if you have a look, I think there's only 1, 2, 3, 4, 5 questions. I think 5 questions per assignment. They're not due until the end of reading break. You've got some time, but like I said, probably good to practice and to get an idea of the types of questions, right? And so I've only picked the multiple choice ones because that's the easiest way to get marks here. But if we go back to the extra practice problems, say for chapter 1, this one, it says it's out of 24, there's just 24 questions. And so you can just try them, do them, see what happens. Here, and on the quiz too, there will be some of these boxes where you type in your answer and then I go in and mark it later. Once you've submitted it, it'll come up with their little blurb of what it had in mind for your answer, right? And so it's up to you to compare what you wrote to the blurb, right, and see kind of if you're on the right track. So it won't mark it right or wrong. It'll just say, okay, well, here's the right answer. So, but here's the reason I like it is because they've already done something like this, right? And so we're going to be interpreting things, and so cholesterol levels, blah, 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 blah. Write down the least squares regression line for these data, right? So we've got HDL is predicting, or the cholesterol is predicting the HDL, and then you just use these coefficients to write out your regression line. Because I'm reading them later, if you do something like, let's see if I can do it on my iPad here. If you did something like HDL, something maybe, underscore hat, even because it's just going to be like a regular keyboard, right? So we have to get creative. As long as you're communicating to me that, hey, here's the predicted value of HDL, right? Equals, and then whatever. Especially hard on the iPad, but you get the idea, right? So as long as you write it out, and then you'll just be able to take the coefficients from here. So it's nice because they've built in all that R code, right? All that R output, and so now we're just interpreting. Okay? And like I said, so these practice ones, they're just going to be open forever, just for you to try, have a look. It's good to have seen a lot of different types of problems, right? So I would, if I were you, I would consider these extra practice problems to be your practice test, right? It's way more questions. Right? We'll talk about the types of questions to expect today, just so you have an idea of what's going to be on here, right? But like I said, do these assignments. These are just to kind of get caught up on marks. There are 5 questions each, multiple choice. You can try them, submit your answer, check them, right? I'm expecting everyone to have 100% on these. There's no reason to not get 100% on these assignments. Right? These ones are just for practice. So, what's this test going to look like? So annoying that it's probably only bothering me, but as soon as I say something, I hear it over here. It's all been muted. I don't know what's going on. It's even told me, hey, you're on mute. Do you know that? I'm like, I am not on mute, apparently. Anyways. So, test number 1 on Wednesday. It will be on Moodle, so bring your laptops. It's kind of nicer to type out your answers too sometimes, and for me to read them. A little bit easier, nicer. Okay. So it will be on Moodle. Bring your laptops. How it's going to be set up is there's going to be 24 questions, and some of them are multiple choice, some of them are fill in the blanks, right? Probably the fill in the blanks will be worth maybe 2 marks, multiple choice will be worth 1 mark, right? And so it'll be more than 24 marks, but kind of the same idea, right? You'll have the entire class time to work on it. And so anything else before I start this run through? There's going to be 24 questions. Nine of which multiple choice. And 15 short answers. Yeah. Mm-hmm. And I've got a list of all the things that we are going to have on there. So I've also decided that I'm going to keep, there's 3 questions that are from the sections that we didn't talk about. They're in chapter 4. You have them available to you. You could definitely sit down, read through it, learn it. I'm going to keep those in there as bonus questions. So there's going to be 3 bonus marks, which is actually a lot, right? Out of 24 questions, 3 questions, multiple choice for bonus marks, but they are going to be from sections 4.5, 4.6, and 4.7. Okay. So 3 bonus questions. And I'm just going to tell you that 2 from 4.6 and 1 from 4.7. Even though we didn't talk about 4.5, but there wasn't one on there, so you're safe. 4.5 is pretty fun though, because it's about coding categorical variables, even if you have more than 1 or more than 2 categories, how to do that. Okay. So, and these are both, or all multiple choice. Of course, in the test, you won't be able to check your answer to see if it's right. You just have to commit to one. Nerve-wracking. What I'll do is I'll set it up so that each of you, they'll be in a random order. So even though we'll go through an order together here, that's just the default ordering, but you'll all have different orders for the questions, which is kind of cool for what we can do with Moodle quizzes. Thanks. First problem on my list, not necessarily the first one on yours, is going to be finding the best predictor. So find the best predictor. And a lot of these notes are probably going to feel a little bit vague, right? But what are some of the ways that we could find the best predictors? If we're just looking at a data set, right? I could look at the scatter plots, right? Which one has the strongest relationship? What's another way that we could measure the strength of a relationship? The correlations, right? And so you've got a couple of different options for finding the best predictor, right? And so it would give you some output, and you just tell me which one you think might be best. Question 2, there's going to be a lot of interpretations, right? And so I'm going to ask you to interpret the slope. So interpret the slope. Interpret the slope. What's the slope? The slope for each unit increase in x, or even x1, x2, x3, right? But let's kind of focus our interpretation on a single regression or a simple regression for now. So for each unit increase in x, we'll see, we expect to see a slope increase in the predicted value of y, right? So that's our definition of the slope, and so you would just interpret it that way. For multiple regressions, right? It's not really the slope. The slope is kind of a dead giveaway that it's for just a simple regression, right? So interpret the slope for multiple regression, right? It would say interpret the coefficients, not the correlations, the coefficients, right? Okay, that's still the predicted increase or the expected increase in the y's, assuming everything else is held constant, right? So for 3, we're going to talk about the residuals. So not necessarily the residual plots, right? Just that the residuals are the distance between the fitted value and the actual value, right? Or the observed value. And we can calculate residuals, right? If I know the observed and I know the predicted, right? The residual is the observed minus the predicted. Oh, any questions so far? No. The fourth question, extra big. H naught is beta 1 equals 0. Remember those t-tests that are all in the output, right? Those t-tests are checking if the slope of that, or if that coefficient is significantly different from 0, right? And so I've put it kind of vague here, right? Do with that what you will, right? But it will have to do with the t-tests in the output for your model. Fifth problem is checking the conditions for inference. It'll give you a series of plots, right? And you will have a bunch of plots to look at in those practice problems, right? And so you have to check, okay, well, is the linearity assumption met? Right? Can I assume that I have a linear relationship? Should I even fit a straight line? The residual plots, right? We're looking for even scatter around 0, right? They should be centered around 0. And random scatter means that we've got this linear relationship, right? Because everything is around a line. And we're looking for constant variance, right? So we're looking for even scatter, because if we have this kind of funnel shape, we said that the line does a great job where the residuals are nice and close together, and then it does a bad job as the points move away from the line. Remember, the residual plots are just maybe it's here. Yikes. Okay, I think we're good. Technology. It's kicking my butt today. Can't connect to the internet. But I think it saved it. That was the problem, I guess. So the conditions for inference, what was I saying? Oh yeah, so we're looking for our residuals have to follow a normal distribution. We have to have constant variance. We have to have a linear relationship, right? Those are our main things that we're looking for. So it'll give you a series of plots to help you determine these things, right? Residual plots. There's going to be 2 of these problems. One is going to be for a simple regression, and one's going to be for a multiple regression. But checking the same things, arguing the same things, right? Just depending on how many predictors we have, maybe the linearity assumption, we won't be able to necessarily check it, but we would say, oh, we assume that, you know, it makes sense to fit it with a straight line. Another test that we talked about, right, is testing the correlation. Is the correlation significantly different from 0? That was among the first few classes, right, where we said, okay, well, I could test the slope if it's significantly different from 0. And in a simple regression, right, testing if the correlation is significantly different from 0 is testing if the slope is different from 0. Right, and so you use that same t-test and the same p-value from that output. And then what was the other one? Oh, the f-test, right, for the ANOVA, where we've got the overview. Right, those are the 3 things, or the 3 tests that do the same thing that we looked at. Right. Multiple regression, it changes a little bit. Then we kind of don't really talk about the correlation anymore because we've got multiples. So then we focus on the f-tests for the ANOVA. Is there something going on in here? And then the individual t-tests for each individual predictor, right? Is the slope of this predictor significantly different from 0? So those will be on there. If you get output and I ask you, what's the p-value for this t-test, for example, you just pick the value, right? Or tell me the value. What's the r squared for this? Give me the r squared. What I've noticed in the textbook, but also in the problems, is that even if we have a multiple regression, right? We said that we were going to use the adjusted r squared, and that's true. But the answers seem to go for just the regular r squared, right? And so I've got it down here further. So I'll make a note of it later when it comes up. But just the heads up that if it's looking for the percentage of variability, right, that's always just going to be your straight r squared. For comparing models, we should use the adjusted r squared, yes. Right? But the percentage of variability in y that's explained by this least squares regression line is still just going to be our r squared. Okay. So values of output. Right. It could be something like, what's the F statistic? Tell me what it is, right? So just given that standard output for either simple regression or multiple regression, be able to pull out values that I ask for. Not, I guess it's not me. Well, I am asking for it. 8. You have to interpret a prediction interval. So interpret a prediction interval. Oops. Prediction interval is for a single outcome, right? And so we said, okay, well, our prediction interval, you guys made your prediction intervals, your confidence intervals. Make sure you keep track of the difference between the two, right? A confidence interval is for an average or, yeah, usually a mean outcome, right? Prediction interval is just for a single outcome, so it's going to be wider, but just be able to interpret a prediction interval. And then later interpret a confidence interval as well, right? But for this point, just interpret a prediction interval. Compare two models, big, again, right? But you're given output for the first model, output for the second model, right? Use everything that you know to compare these two and tell me which one is better, or if there was an improvement in the second model. So compare two models. So here we already talked about this one, but we're going to interpret a coefficient in a multiple regression, right? And so I'll give you output and then interpret the coefficient of this thing, right? Well, that's how much we would expect the predicted value of y to change for each unit increase in the one that we're interested in, right? Assuming everything is held steady, right? Everything else is held steady. And so interpret a coefficient in multiple regression. So again, question 11, you've got conditions for inference, like I promised. You have to check the conditions. Most like this is going to be, I said one was going to be for a simple regression, one's going to be for multiple regression. Here we're into multiple regression stuff, right? So this would be the multiple regression. But like I said, the order for you guys will be different, right? The questions will be all mumbo jumbo. So question 12, again, you have to interpret the output. And so interpret the output. Completely unrelated, but a side note that I would like to put here is, it's not completely unrelated, no. The percentage of variability. The percentage of variability in Y explained by the model is always R squared, right? Even in multiple regression. Because that's the one thing that I felt like I didn't quite emphasize maybe enough in class, so putting it on here. So the definition of R squared, right, is the percentage of variability in Y that's explained by the least squares regression line on X or multiple regression. So that's always going to be R squared. For comparing models, use your multiple R squared or your adjusted R squared. But for the percentage of variability, it's R squared. 13 is again kind of vague. Interpret the output. In this case, it might ask something like, should you remove this value, right? Should you remove this predictor? Or if I give you a set of outputs, right? Or if I give you a model, would you keep all these predictors? Would you be able to get rid of one? If so, which one, right? That kind of thing. So just interpreting the output. (14) you have to interpret the confidence interval for a coefficient in a multiple regression. So maybe have a look at that. Interpret a confidence interval for a coefficient in a multiple regression. So we're 95% confident that this interval captures, you know, whatever we're talking about. The true slope for the third coefficient or something, or the third predictor. Okay. 15 is on the variance inflation factors. It'll give you the variance inflation factors, and then what do we use the variance inflation factors for? It's to check for multicollinearity. What did we say about multicollinearity is, well, it's fine. We just need to be aware that that's what's happening, right? We need to be aware that these predictors are correlated, right? And so what was one of the glitches, right? It means that interpreting those coefficients and their p-values is a little bit trickier, right? Because things are going to move together. And so we can't just hold, you know, 3 out of the 4 steady and look at the 4th one. They will move together. So it makes interpretation a little bit trickier, right? But we just need to be aware if it exists, right? It's not bad. It's not necessarily good, but it's just something that we need to be aware of, right? And so high values of the variance inflation factor, something over 5, right? That's when we have multicollinearity and things are, our predictors are correlated. 16. Pick a test to run. So if I say, oh, I want to check to see if any of the slopes are significantly different from 0, right? That would be an ANOVA and F test, right? What if I want to know if I can pull out some of these predictors, right? 2 out of the 4 predictors, then I could run a nested F test, right? What if I want to test to see if a single coefficient or a single predictor is significant to the model? That would be the T test that we're looking at, right? And so just kind of pick a test that satisfies what we're asking for here. 17. Conclusion from the output. Again, really just interpreting the output. What does it mean, right? This one, off the top of my head, I can't even remember what the question was. All the other ones, I'm like, oh yeah, that's the question, that's the question. This one, I'm like, well, conclusion from the output. Who knows? Maybe it's that something is significant, right? Is there something going on in here? Who knows? This one I'm keeping in here. We didn't really talk about interactions between 2 quantitative variables, right? 2 numerical variables. But maybe look into it and be able to explain why we might want to do that. So an interaction term between 2 quantitative or numerical variables, quantitative / numerical, whichever you prefer, variables. I'll put in brackets. Explain why we might use it. Remember the interaction term, if we boil it down to just the binary situation, right? It allowed for different slopes for 2 different groups. Now we're allowing for, so instead of 2 different groups, now we've got a quantitative, right? Can be on a continuous scale, right? So now we're allowing for different slopes depending on different values of the one quantitative variable, right? And so it just allows for different slopes. But for more than 2 variables now, potentially on a continuous scale. 19. Oh yeah. An indicator variable. Indicator variables, right? We've used it for gender, 0, 1, right? Someone lives, they die, right? 0, 1 situation, so that's an indicator variable. I'll say interpret the model. So you'll have a model with an indicator variable. What does it mean? Maybe build the models for both of them. Any questions so far? I trust you'll stop me. So 20, we'll do a 90% confidence interval interpretation. I mean, the percentage doesn't actually matter. Is there a qualm? Is there a qualm? Question? No. "21 is a long list of problems." Hey, 24 sounded so easy. It's 24 questions, no big deal. And then we list them all. Oh, 21. On my list, it's the 4.6 bonus. I will clearly indicate which ones are the bonus questions, right? Because I am kind of letting you do your own study work, right? If you want to get these bonuses, great. If you don't, see if I care. Same with 22, I'm pretty sure is also the section 4.6 bonus. So I mean, honestly, if you just read up on 4.6 and had a pretty good idea, that's 2 bonus marks. And then 23 is the section 4.7 bonus. So I didn't count those bonus questions in the 24 questions, right? So 24, so there's 3 more after this. Is another question on the variance and inflation factor. Because we did talk quite a bit about those, right? And so again, it's just kind of another approach, another type of problem. Very similar though. See? 25 is just comparing backward elimination to forward selection. Right? What are the differences between the two? So backward elimination versus forward selection. '26 is going to be dealing with outliers, right? So what do we do if we are faced with outliers? Well, we're going to fit the model, right? See how the model behaves. If it's good enough with the outlier in there, then we keep it in there, right? Versus, okay, well, if I remove that outlier to see how my R squared changes, for example, right? Then I have to make a decision after that. Dealing with outliers. And then finally, we're going to make a prediction using a log transformed model. So it's a prediction using a log transformed model. So then you have to undo the log, right? And it's always going to be the natural log, right? And so you're going to take, so whatever your answer is going to be the log of y, right? To get y on its own, right, you have to take e to the power of your answer, and then you'll have your answer. Right? And that's it. No problem, right? But hopefully it gives you a better idea of what to expect. Yeah. Yeah. because the questions are from the authors. So definitely. And so that's why I gave you all those practice problems too, those extra practice problems, because they're also from the author, just to see how they might word things, and just so it's not so strange when you get in there, right? Just exposing yourself to the different types of problems, even though they're not necessarily exactly like these, right? They get you to think about the same issues, right? And so that's the test.
What do you exactly mean by interpret 90% of confidence into question 21?
Oh, same as before, right? So we've got if I give you a 90% confidence interval, it's probably going to be, I can't remember if it was for a coefficient or something, but let's say that the slope, right? Then for a 90% confidence interval for beta 1 is that we're 90% confident that this interval captures the true slope for this relationship. Right. Any other questions? No? Yeah?
The time duration for the test?
Oh, you get the class. Yeah. So you'll have the class time on Wednesday. So I guess it's an hour and 20 minutes, right? Yeah. Then we deal with that on Wednesday.
As I'm using the net right now, that's why it's really.
Are you on Eduroam or are you on the OC Wi-Fi? Oh, okay. Because I was having troubles with Eduroam, but that's not good. We'll assume that it's gonna be fine. And then if it's not, then we'll deal with that if it's not. Yeah, don't worry. But hopefully it's okay. Any other questions? No? Okay. 10:20. What did I have? I feel like we were gonna finish some stuff last day. What were we talking about last day? Oh yeah, the outliers. Okay. Okay, that's one of the problems on here towards the end, right? Dealing with outliers. Maybe to motivate ourselves to for what we're talking about today. I'll say dealing with outliers or identifying outliers. Because that's what we're doing here. And something tells me that's actually what I meant. So I was like, oh, I have to finish that on Monday. Okay. But any questions before we keep going with the notes from Wednesday? Because what were we doing here? We were looking at this plot, right? And we were talking about leverage as a measure of how much leverage this outlier would have, right? And we said, okay, well, if we have k predictors, then leverage, which is denoted by h subscript I, that's just our leverage. If it's greater than 2 times k plus 1 over n, so it depends on how many predictors you have and how many things you have in your sample, right, your sample size, then we would say it's somewhat high leverage if greater than 3 times k plus 1 over n. That's very high leverage. That's not something that I'm expecting you to memorize, but these things, somewhat high, very high leverage, are being used down here in this graph, right? Because down here we've got the leverage, right? And so here at this point, they've calculated that you have somewhat high leverage using that 2 times k plus 1 over n. Here, 3 times k plus 1 over n, whatever that is, and then they put those lines on here. And so we talked about the leverage lines. Copy. I'll put those in our notes for today. So from last day, and I'll even make this a little bit bigger so we can. Here we said we had somewhat high leverage. Oops. And then here we had very high leverage. If we go to the y-axis, right, the y-axis has the standardized residuals. Remember, the residuals are the distances from the line, right? So how far away are these points from the line? We're expecting them to be around 0, right? Especially the standardized residuals, because they're standardized taking into account the spread of the residuals. But here, let's talk about the residuals. We talk about 2 different types of residuals. I would say they behave the same way though. So we'll just talk about them. But like here, we've got the standardized residuals. And so those are usually the ones that we focus on. So a standardized residual, I'll say number 1 is a standardized residual. And it uses the regression standard deviation so essentially the overall spread of all these residuals, whereas the second one, the studentized residuals, uses the same standard deviation, right, but with that point removed, right? So what would the standard deviation be with that point removed, right? And so the studentized residual uses the regression standard deviation with the outlier removed. Yeah. Both of these, right? They both behave the same way. Right. Any residuals beyond plus or minus 2, right? And that stems back to the 68, 95, 99.7 rule, right? If you're more than 2 standard deviations away, then we can consider you to be extreme, right? Not within the central 95%, right? And so the residuals behave the same way. And whether we're talking about the standardized or the studentized, any residual that's larger than 2 will be considered extreme, right? And so any residuals beyond plus or minus 2 are considered moderate outliers, are considered moderate outliers. And beyond plus or minus 3 are considered serious outliers. Serious. Considered serious outliers. Which translates to our plot, right? Because here, well, here's our residuals. If we're going from 0 to 5, right? 0, 1, 2, 3, 4, 5, right? Pretty reasonable. And so we've just put lines at -2, +2, -3, +3. And so now we've got these borders, and now we can look to see, okay, well, I've got this point over here. That's definitely beyond 3 standardized, no, 3 standard deviations away in our standardized residuals. Long story short, considered extreme. Right? Even this guy, it's more than 2 standard deviations away, right? It's on the 3 standard deviation line. So you're going to use this to see, okay, well, if there's anything that's beyond these lines, right? 2 standard deviations, 3 standard deviations, right? It helps us gauge how extreme things are. So here, I'll do plus minus 2 standard deviations. Oh, gotta use a different color. Oh, I already used that one. Ah. All right. Hopefully it's more obvious, right? Yeah.
For the points that are beyond covered or considered extreme and their effect with respect to the slope of your model.
Sometimes. So we use this. So we use this plot to identify outliers, right? This one and this one. And even these points we would have to check out because of their leverage. Often we're more concerned about the leverage, right? Because they're kind of leveraging our line. And so, but to use this plot, right, what we do is we use it to identify, okay, I'm going to check out this point. I'm going to check out these points. It looks like there's more than one here. Right? And I'm going to check out this point. Right? And so that's how I say, okay, well, here are the outliers that I am going to have a look at. And then I'm going to fit my models. And I'm going to kind of alternate things back in, hold them out, see what happens. Right? So we use this to identify potential outliers. Okay? Here, these lines are what we call the Cook's distance. The Cook's distance is the one that we kind of ultimately rely on because it combines how far the residuals are, right? How many standard deviations the residuals are away from each other, as well as the leverage. Right? So it's a combination of the two. And of course, it's got kind of 2 bounds as well. Right? So here. So Cook's distance combines how many standard deviations? Combines how many standard deviations a point is away from zero. How many standard deviations a point is from, or sorry, a residual, I should specify, not just any point. A residual. Say that again.
No, it's
So it combines, it's just a long sentence. It combines how many standard deviations we are away, but also the leverage. So it combines how many standard deviations a residual is from zero with the leverage of each point. Cook's distance is denoted by a capital D subscript I, denoted by DI. And the textbook does go through, and I am pretty sure they show you how to do it, but it just combines the leverage HI with the residual. But what we say is that a DI greater than 0.5 is moderately influential, and a Cook's distance that's greater than 1 is considered very influential. So on our graph, right, here, I'll do it in purple because that's what they are, right? These lines here, these are Cook's distance. And ultimately, they're the ones that we check to make sure if we have any outliers, right? And so because it combines, right, if we have this huge value here, it has high leverage, right? Even though, well, that one's bad. This one's kind of within the bounds, right? But these ones have high leverage, but the residuals are close to zero, so we let them slide, right? Because we don't just focus on the leverage. Here, what we're going to do is we're going to look at these bounds, right? And here's a 0.5 Cook's distance, and here's a Cook's distance of 1. And because it's a combination of how far away they are, right? How many standard deviations away the residuals are from zero, and their leverage, right? We get these sort of curved bands. Convince yourself looking at the equation, but I don't think you need to. Right? Just look at these. So now what we say is, okay, well, looking at 0.5 of a Cook's distance, right? Anything greater than 0.5, I've got 2 points. Anything greater than 1, right, is a, what did we say? A very influential point. That's right. So we have 2 very influential points in this data set. Right. So we would focus our outlier analysis, right, on these 2. And if we still can't quite get a good fit, then sure, we can kind of look at, okay, these leverage points, but typically we just focus on the ones that are outside the Cook's bands, let's call them.
You need to all those, and or you can just.
R usually generates all 3. It just does them. So if you use that plot of the model command, I think this is one of the ones that it gives you. Like, think some of you have had a look at those. And so, but it definitely gives you the Cook's distance, and that's the one that we're going to focus on. Right? And so I'll say here, this line is a DI greater than 1. Very influential. And this line here is a DI greater than 0.5. And I think we said somewhat influential. And then same thing on the lower bound. Right?
Can you calculate whether it's greater than 0.5 or 1 on the graph?
Oh, on the graph?
I know, I mean, we get DI values.
Yeah.
We do that plot.
Yeah.
How can we interpret that? Okay, fine, this line is greater than 1 or 0.5. Like, should we consider y-axis points or x-axis is like, anyways, we can't consider. They're all.
Well, you won't have to make this line because it'll just draw this line for you.
Okay.
Right, and so all I want you to do is be able to look at this and tell me if there are any influential outliers on here. Right. Yes, there are 2, this one here and this one here, both of which are more than 1 Cook's distance away. Right. If you had, so let's say this one was scooted in between here, right? Then you would say that there's one that's somewhat influential and one that's very influential. Because it's in between those bands. I don't think that really answers your question, but that's what I want you to do for this one.
But we just have to remember the very first line is greater than 1 and the second one is 0.5.
Yeah, because if you start, because it will all start around 0 anyways, and then you're moving out, right? So 0.5 and then 1.
Okay.
Good. So we will focus on using the Cook's distance on the plot to identify if there are any outliers, or to identify if there are any outliers. And also to classify them as very influential or somewhat influential. And also to classify them as very influential or somewhat influential. We had to talk about the others because Cook's distance takes them both into account. Right? But now that we've got Cook's distance, we can just focus on Cook's distance and use that. Any questions? I was going to go through 4.5, but as you've seen, there are no questions on the test for it, and I'll just leave it for you guys to go through. But the long story short, it's actually not a long story. It's if you have, and we already said, so if I have a categorical variable with more than 2 categories, right? If I'm coding those, what I do is I make an indicator variable for each of the categories, right? So I might have for indicator variables, right? If I've got 4 categories, what I do is I include all of those individually, right? Except for the one, right? So if I have 3 categories, I use, or if I have 4 categories, I use 3 indicator variables, right? Because I've got category 1, category 2, category 3, category 4. So for my indicator, I've got either you're in category 1 or you're not. Either you're in category 2 or you're not. In category 3 or you're not. In category 4 or you're not. Then we pull one away because we only need 3. And then we can figure out the 4th one, right? And that's what the model does. It just figures out what the 4th one is and uses that as your reference, reference coefficient, reference category. That makes more sense. So that's the idea. But like I said, on the test, so I won't waste your brain space. How about that? But it is something fun to keep in mind. Any questions? Questions to help you prepare for the test on Wednesday? No? Okay. Well, that's all I've got for today. I did post lab 3. Lab 3 is just a couple of questions, or I think 3 questions, but not too bad. You're going to use the baseball data, and we're just testing out, so the forward selection, the backward elimination, figuring out how do we get mallow C, right? Things like that. And so these are just things that I essentially just want you to Google your way to, right? Kind of, how do I do this? How do I do this in R? How do I do this? How do I do this? And then we do a little cross-validation example. Right? We hold out, we build our model, we test it on the holdout sample. And then we have a look at some residuals. But that's about it, right? And that's lab 3. I won't make this due, right? Because I want you to have a lot of time to work on it, or at least a lot of time to not work on it. So let's have this due Sunday night, the 23rd. Does that work? So it's the Sunday of reading break before we're back to school. How about that? So lab 3. Lab number 3 is due February 23rd at 11:59 by email, of course. Okay. And I know I'm way behind on marking your stuff. I marked your, can't remember what, the first lab. Yeah. So sorry. I'm working on it. It's just, yeah. So let me know if you have any questions about that, but otherwise we'll just meet over in the H building, per usual. Any questions? No questions? Oh, I sent out an email, was it last week? Did everyone get that email? Because I just stole your personal emails, I think. Is that okay? Is that an okay way to contact you?
Yes.
Okay, cool. Because contacting through Moodle is just kind of annoying.
Yeah.
Yeah. Good. Okay. So then that's how I'll contact you from now on. Awesome. All right. No questions? See you guys over in the H building. Cool. Or not, I don't care.